Today we are going to talk about subtracting sign numbers in section 8.3. Before we get into the actual subtraction, we're going to revisit our definition of opposite. So we talked about in the first section our definition of opposite. Opposites are the numbers that are the same distance away from zero but lie on opposite sides of the number line. What we did in our first section is we looked at these just using words. What is the opposite of positive 2, or what is the opposite of negative 2, or something along those lines. In this case, in this section, what we're going to do is we're going to look at this using our negative sign to mean a opposite of a number. All right, so in this first example, we're going to start by rewriting our phrase in words. And then evaluating what that phrase is going to be, and then we'll kind of generalize this process down at the bottom of the page. Right? So if we have a negative sign outside of a positive 7, this means that we are looking for the opposite of positive 7. Right? The opposite of positive 7 is negative 7. Right? This next one means the opposite of 8. Well, that 8 is positive, so the opposite of a positive 8 is a negative 8. Right, this next one means the opposite of negative 5. The opposite of negative 5 is positive 5. Right, this next one means the opposite of negative 11. Right, the opposite of negative 11 is going to be positive 11. Right, now with this next one, notice that we have a couple of sets of parentheses. Right, so what we have here is the opposite of the opposite of negative 2. Right? So to think about this, we're going to kind of start at the beginning and work our way outside. Right? So if we start with negative 2 and we work out to our first negative sign out here, right? That means we want the opposite of negative 2. Right? So the opposite of negative 2 is positive 2. And then if we work back to the beginning of the phrase, or this last negative sign out here, right, we've taken our negative 2, we changed it to positive 2, and then to find the opposite, we're going to change it back to a negative 2. Right? And the reason I put this one in here is to kind of generalize a couple of rules or different things that we're going to see. Right? In all of these cases above, right, where we have exactly one negative sign, or as in this last case where we have 3 negative signs, we end up with a negative answer. Right? C and D, where we have 2 negative signs, we end up with a positive answer. So when we're thinking about opposites in integers, right, we can kind of generalize what we just did in the previous example and say the result is going to be positive if there is an even number of negative signs. Right? That was example C and D. Both of these have 2 negative signs. 2 is an even excuse me. 2 is an even number, and our end result is positive. We're taking the opposite of a negative number. Right? Now, in A, B, and E, we have an odd number of negative signs. And in A, B, and E, our result was odd. Right? So that means that we're taking either the opposite of a positive number or the opposite of a negative number. Right? And as we alternate back and forth, we're going to alternate between even and odd. So if we see 2 negative signs together, right, we have an even number of negative signs out front, that's going to mean that we're going to have an even number of negative signs means we're going to have a positive answer, right? And if we have an odd number of negative signs, we're going to have a negative